Over millions of years, animals have adapted and evolved an arsenal of deadly weapons to hunt, defend, and attack. Teeth, claws, antlers, electricity, stings, camouflage, odor and poisons are all being used to devastating effect in the animal armory. In the frigid waters of the Arctic, the walrus depends on its surprising ability to spit in order to feed. For the cobra, its venomous projections are fired with intent to blind their predators. And for the jawfish, spitting provides them with a home and the means to defend it. When it comes to stings, individual bees will sacrifice themselves to attack a threat to their colony. Jellyfish trawl their stingers through the world's oceans to capture prey and ward off predators. In Australia, the humble echidna is coated in a near impenetrable armour of spines. Stingrays, despite their infamy, reserve their deadly sting for self-defense. Whereas predatory centipedes deliver a paralyzing sting to immobilize their victims. A treacherous and ever-changing frozen landscape, the Arctic and its surrounding waters are among the most hostile environments on the planet. Few animals are equipped to survive in the Arctic's harsh climate, and fewer still can appear comfortable in this sub-zero world. But the rotund, easygoing walrus provides exception to the rule. Highly social animals, walruses are commonly found in massive herds, numbering in the tens of thousands. Between feeding and fighting, much of the walrus's time is spent lounging about in an environment where most animals would perish. Conserving energy as they rest, walruses are protected from the elements by a tough hide encasing an insulating layer of blubber up to 10 centimeters thick. Famed for their tusks, the walrus's elongated canines can reach a meter in length. A potentially fatal instrument in self-defense, the tusks are also relied upon during the breeding season, when males engage in fierce combat to establish social dominance. But the walrus has another unexpected weapon in its arsenal. One that is commonly used but rarely witnessed: spit. With adults weighing up to 2 tons, the walrus's tremendous bulk makes them slow and cumbersome on land. But in the water, the walrus suddenly becomes agile, and it is here that their secret weapon comes into play. Feeding primarily on mollusks, the walrus must consume about 5% of their body weight per day. This translates to between 3,000 and 6,000 clams in a single feeding session. Fossicking in the murky depths, walruses must locate and remove their stubborn food source from the sea floor, and they rely on spit to do so. Drawing large amounts of water into their uniquely vaulted mouths, walruses are able to fire a high-pressure jet stream at the otherwise inaccessible mollusks. Clearing out the surrounding debris, the walrus's spit reveals and loosens their food source, allowing for easy removal and consumption. And once the soft flesh has been devoured, the walrus simply spits out the remaining shells. As effective as their unique spitting technique is in feeding, it is often little protection against the Arctic's other predators. While healthy adult walruses are more than capable of defending themselves, polar bears will rush the herd on the beach, attacking any individual that is crushed or injured in the sudden exodus. Even in the water, they are not entirely safe, with killer whales known to target calves or otherwise unwary walruses from the depths. With their predators equally determined and well-equipped, the seemingly relaxed walrus must remain ever ready in the unforgiving Arctic. From the tropical forests and grasslands of Southeast Asia to the dry savanna and arid regions of southern Africa, the cobra strikes fear into all that cross its path. And this is by design. The name cobra is derived from Portuguese for hooded snake. There are over 20 species of true hooded cobras spread across 2 continents. And it is this intimidating appendage that lends this snake its fearsome reputation. But the cobra's hood hides a secret weakness in this seemingly indomitable animal. While non-venomous snakes such as boas and pythons will grab their prey and squeeze them to death, cobras rely on venom to kill. With relatively small fangs and a slender build, cobras are more vulnerable during these hunts than their bigger, more muscular counterparts. Needing to bite down and hold on to their prey in order to deploy their deadly venom against smaller animals, this aggressive technique poses little danger to the cobra. But against larger game, such as rats or even other snakes, if the cobra fails to disable their quarry immediately, they can easily be injured or killed in the ensuing struggle. This is where the fearsome hood comes into play. Rearing up to display its characteristic flattened neck, the cobra appears bigger than it actually is, effectively bluffing its way out of dangerous situations. It is the dramatic impact of this unique display that has made the species a favourite of snake charmers. But some cobra species have another, more dangerous weapon in their defensive arsenal. While all venomous snakes secrete venom from their fangs, spitting cobras have modified this trait to launch long-range assaults. By contracting the venom glands, spitting cobras squeeze small amounts of venom at high pressure through their fangs. Enlarged fang holes direct the venom upward and outward. The snake simultaneously flaying its head to widen the target area of the spray. Projecting over 2 meters with lightning speed, the venom combines neurotoxins and cytotoxins, allowing it to damage nerve tissue and shut down individual cells. If this deadly spray is inhaled or comes into contact with a cut, it can cause serious damage. But the real target is the eyes, with the cobra seeking to blind its attacker. Predated upon in the wild by birds of prey, rival snakes and mongooses, for spitting cobras, this vicious defensive mechanism can be a lifesaver. So instinctive is this ability that baby snakes are able to spit immediately after hatching, and some species have been reported to spit even after death. Found throughout the Atlantic, Pacific and Indian Oceans, one species of fish has evolved its talent for spitting to be used in a variety of applications. Small and charismatic creatures, jawfish average just 10 centimeters in length. Occupying challenging terrain and ready to duck for cover at the slightest hint of danger, there are currently over 80 described species of jawfish, with more being discovered all the time. Exhibiting great variety in their appearance, they share the common attributes of enlarged heads, bulbous eyes, and cavernous mouths. The huge mouth of the jawfish is kept busy digging burrows. Spitting excavated material to one side, jawfish tunnel vertically into the sea floor in order to create cleverly engineered burrows. It is here they will spend the majority of their lives, safely ensconced from the ocean's myriad of predators. Scooping up mouthfuls of sand, pebbles and coral rubble into its enlarged mouth chamber, the jawfish contracts its gills to force the debris back out again. Narrowing the mouth opening creates increased pressure, allowing the jawfish to fire targeted debris at unwelcome intruders. Unable to either outswim or fight off the many predators that target them, jawfish are extremely vulnerable in the open water. Rarely venturing far from their burrows, their remarkable mouths are their greatest asset in preparing and maintaining a ready escape route. When danger has passed by, a jawfish will cautiously check that the coast is clear before re-emerging from the safety of their burrows. While their spitting is not an effective deterrent to predators, it can be used against fellow jawfish. Investing so much of their energy into digging and fastidiously cleaning their burrows, it is no surprise that jawfish are highly territorial. And when a rival crosses the boundary, the resident jawfish will accurately spit gravel in a sign of aggression to ward the intruder away. But the jawfish's reliance on its mouth does not end with digging and spitting, with the males of the species also practicing mouth brooding. Carefully incubating their eggs while holding them in their mouths, the fathers-to-be will open wide to aerate their young, foregoing food themselves until the newborns are hatched. As the day draws to a close, the jawfish retires to the safety of its burrow. Covering and perfectly concealing the entrance, they may sleep safely within. When it comes to stings, for most there is one animal that comes immediately to mind. Perhaps the best-known member of the insect world, the bee. With close to 20,000 species and a distribution covering every continent except Antarctica, bees are a remarkably diverse group of insects. Not all bees make honey, and not all bees are able to sting. But for the many different varieties of honeybee, stinging is a vital defense mechanism in protecting this invaluable resource. As pollinating insects, bees are dependent on flowering plants for their survival, and vice versa. So while the bee's armory is not to be dismissed, it is the mutually beneficial relationship with their food source that has assured their survival, with plants and bees co-evolving for tens of millions of years. With the bees traveling from flower to flower, they transmit pollen from one plant to another, allowing the plants to make seeds and reproduce. For the bees' part, the pollen they collect is stored in their hives, where it becomes honey to feed the colony. And it is in defending this hive where the bee's sting is most useful. honeybee stings using a modified egg depositor called an ovipositor. Barbed at the end, when the stinger enters its victim, it lodges, enabling venom to be pumped from the venom sac. This process triggers the release of alarm pheromones from the bee, drawing other bees to join the fight. While capable of repeatedly stinging thin-skinned animals, when it comes to thicker-skinned mammals, such as humans, the honeybee's barb is lodged tight, tearing loose from its abdomen and causing its death. However, the relentless sting lives on, pumping venom until its sac is completely drained. For bees, their sting is often a last resort, with their astonishing abilities in the air generally able to get them out of trouble. While it is a common misconception that bee flight defies the laws of physics, their aerial mastery is certainly uncanny. Flapping their wings approximately 230 times per second, bees are capable of attaining speed, height, precise maneuverability, and carrying relatively heavy loads. But for all their advantages, bees know a great many predators in the wild. Among them, their close relative, the ant. Seizing individual bees while foraging or raiding hives for the energy-rich honey stored inside, ants pose a constant threat to many species of bee. Social insects, the inspiring teamwork of honeybees is evidenced in their intricately structured, highly organized hives. With clear division of labor, shared care for the young, and complex communication networks, a healthy beehive is a perfect picture of harmonious living. While their sting remains a dangerous weapon, the bee's greatest asset is their ability to cooperate. In this episode, we have seen how spits and stings are incorporated in the animal world in equal part for attack and defense. The walrus has proven an unexpectedly frequent spitter during its underwater forays in search of clams and mussels. The cobra is unique among the snake world for its ability to fire venom from its fangs to blind would-be attackers. Jawfish feature enlarged mouths to accommodate their spitting habits in creating and protecting their homes. When it comes to stinging, bees employ their stinger in self-defense and to call on reinforcements when defending their hive. But stings come in a variety of forms, and for every stinging animal, there is a distinctive variation of the theme.